Hello everybody and welcome back to Chemistry News. I hope you are taking care of yourself and your family during this pandemic of coronavirus. Talking about, the coronavirus pandemic, ethyl alcohol has been very efficient during these times in keeping us safe. And being more specific, ethanol has been making time pass by really nice for many adults.
This is why today we brought the groundbreaking scientist in regards to alcohol, which will show us an experiment and help us talk about the two methods of production of ethanol.
Yes, but first let's talk a little bit about when and where has been ethanol created. Ethanol has been used by humans since prehistory as an intoxicating ingredient in alcoholic beverages. Absolute ethanol was obtained in the 1796 by Johann Tobias Lowitz by filtering distilled ethanol through charcoal.
A chemical reaction called fermentation takes place during the production of alcohol. The glucose is broken down into ethanol by the action of enzymes. Yeast is a single-cell organism and it is a type of fungi. It contains the enzyme zymase that acts as a catalyst during the reaction.
However, this experiment does require some conditions. The temperature must be between 25 and 50 degrees Celsius. This is because enzymes are affected by this temperature. If the temperature is too cold, enzymes move slowly. However, if the temperature is too high, the enzymes will denature, making the substrate no longer fitting. Another condition is the substrate. Glucose solution, as we know, works best on enzymes when they are at a high substrate concentration.
There are two more conditions for these reactions to take place. First, absence of oxygen. Air must be excluded from the vessel where fermentation is being carried out. Why? Because air contains a bacteria called Acetobacter. This bacteria uses atmospheric oxygen from the air to oxidize ethanol in the wind or in the air, producing a really weak solution of ethanoic acid. And the second condition is that yeast must be present during the fermentation of glucose solution of ethanol, because without yeast, the reaction cannot take place.
For this experiment, it is crucial for you to use safety glasses. In this experiment, we will divide the ethanol from a beer. We begin by putting the beer in the Erlenmeyer flask. It is preferable if you leave the beer overnight so that there is no bubbles in it, but you can do the experiment anyways. Then I placed the bunch with the delivery tube. After I secured everything, I placed the flask over the heat. And with an infrared thermometer, we measured the temperature. As we saw vapor going up, we quickly actioned and put a freezing cold pad on the delivery tube, therefore condensation would happen. If you're doing this at home, remember to always have an adult present. As you can probably see, there's a lot of vapor going up, which in theory should go through the delivery tube and then condensate due to the freezing pad around it, and then drop into the test tube. The liquid that drops in there is ethanol, which has been condensed from the beer. After heating the beer for around 10 minutes, we decided to stop and test if what really was in the test tube was ethanol. By this, we mean that we dropped it in a container and we tested it with the flame test. As you can clearly see, the alcohol that we received in the test tube was ethanol. And now when we turn off the lights, you can clearly see it. This experiment you saw, where ethanol is divided from its drinking alcohol, may seem very cool, but the production is too. One way is by manufacturing alcohols with alkanes. Ethanol is manufactured by acting ethane with steam. The catalyst is used in solid silicon dioxide coated with phosphoric acid. The reaction is reversible.
Only 5% of ethane is converted into ethanol at each pass through the reactor. By removing the ethanol from the equilibrium mixture and recycling the ethane, it is possible to achieve a 95% conversion. This way is called hydration of ethane. In this reaction, ethane, which comes from concrete crude fractions, is heated with steam in the presence of a catalyst of phosphoric acid to speed up the reaction. This reaction typically uses a temperature of around 300 degrees and a pressure of around 60 to 70 atmospheres.
Notice that ethanol is the only product. The process is continuous. As long as ethane and steam are fed into one end of the reaction vessel, ethanol will be produced. These features make it an efficient process. However, ethane is made from crude oil, which is a non-renewable resource.
The other type of production is by alcohol fermentation. Fermentation is a metabolic process taking place in the absence of oxygen. The resulting products have a better flavor and more life as they are preserved. They also provide many health benefits.
Today we will concentrate on ethanol fermentation, also called alcoholic fermentation. It's a biological process which converts such glucose, fructose, and sucrose into cellular energy, producing ethanol and carbon dioxide as byproducts. Because yeasts perform this conversion, in the absence of oxygen, alcoholic fermentation is considered as an anaerobic process.
It also takes place in some species of fish, most knowingly goldfish and carp, where along with lactic acid fermentation, it provides energy with oxygen where it's scarce. Ethanol fermentation has many uses, including the production of alcoholic beverages, as you just saw, the production of ethanol, fuel, and bread cooking.
Now we are going to see a table that compares both fermentation and hydration of ethane.
We will also talk about the production of ethanol in Argentina.
The purpose of the production of bioethanol in Argentina is based on the sugarcane plantation system. With extensive use of agricultural land, scarce use fertilizers, pesticides, and artificial irrigation, and burning of sugarcane prior to harvesting. The objective of this paper is to develop a life cycle system, LCA, of the fuel ethanol from sugarcane in Tucumán, assessing the environmental impact potentials to identify which of them cause the main impact.
This approach innovatively combines knowledge about the main impacts pathways of bioethanol production with LCA, which covers the typical emission-related impact categories at the midpoint life cycle impact assessments.
That has been all for today. We hope you have learned something new, and come back tomorrow for more information.